Hi, good morning, everyone, and welcome to the seventh edition of International Congress on Information and Communication Technology. We have been doing this conference since inception, and I'm very proud and very happy to see that this conference is growing on its own pace. So from the first version, with a journey of 200 papers that time received and approximately 12 countries, in the seventh edition, we have reached to almost 98 countries and around 1,200 papers. So it's a big journey we have traveled over the time. And I thank you all for contributing in any of the forms you are doing. Maybe you are an author, maybe you are a speaker, maybe you are a chair, in any form, and I really appreciate the efforts made because this is not a very easy task to spend time and to contribute towards research. But in whatever way you are doing and whatever form you are contributing, I really appreciate and thank you so much for this. So we will be starting with the formal inauguration of this session, and we have lots of speakers on the list before we move on to the technical sessions. About this edition of the conference, we have received almost 1,200 papers, out of which we are publishing, with the help of Springer, 300 papers and 4 volumes of LNS series. So that is a big number, but beyond this big number, there is a lot of efforts made by the whole team of this conference, specifically the reviewers and the supporters who have took time out to see the paper, to check the quality of the paper, and then decide on the decision of the paper. So I think that this is the most tedious task a conference can ever do in reviewing the papers. We can arrange everything else. It is quite easy, but the reviewing of papers is quite difficult. So I thank my whole team and the review committee to be a strong part of our team. We will be also sharing few of the technical sessions in next couple of days, and there will be total of 43 technical sessions which will run in parallel, 5 sessions in parallel from today noon to tomorrow evening. So this is how the 43 sessions, every agenda is available and anyone can join the agenda just clicking the Zoom link on the conference website. It has been managed so easy for everyone. So you just search your session and you just click on the Zoom link and you'll be allowed to participate. That's fine. Moving ahead, I would like to thank our publisher, which is Springer, in this conference and supporting us and helping us with technical inputs to take this conference to much higher heights. And this is the seventh time, and the seventh time Springer is a publication partner for this conference. And representing the publisher here, we have with us Mr. Bose. So I thank you, Mr. Bose, for your efforts during the tenure of this conferences to provide your technical inputs to make this conference more richer in terms of quality and quantity. Thank you so much. We have with us Professor Mike Henchy, who is the president of International Federation for Information Processing, and he's contributing to the things in his own way because he's he's the president of one of the international organizations formed by UNESCO, and he's supporting this conference since I think 2017, and we have been meeting with him over the time to take his technical inputs and just increase the quality of our conferences. We have with us Professor Jyoti Chaudhary, who will be a next speaker today, and she is the professor at the University of Hertfordshire, and she is also contributing. And this year we also have taken her on board in one of our conferences. So I think this association will last long in the times to come. We have with us Dr. Nilanjan De. Coincidentally, it's his birthday as well. So I wish you a very happy birthday. And so he's one of the editor of this conference since inception. And over the time, his technical inputs have also helped this conference to take to newer heights. And we have with us Dr. Melan Tuba, who is also a very good associate with us since long. I think I've been meeting him every year every year twice, but last 2 years of pandemic were really rough. We were not able to make it happen. But at this point of time in London, we met him at our physical version of the conference. So we missed you all, guys, at our physical version of the conference, which happened in London on 21st. But we hope that next year, when in 2023, the 8th edition, people will travel and people will be meeting physically, and I expect all of you to be there in physical presence, because conferences is not just about the presentation, it's about networking, it's about pitching the people, meeting the people, and sharing the thoughts which can connect over the time. So thank you so much. And unfortunately, we have another editor of this conference, Dr. Zheng Xiang, who is not able to be present in this digital conference due to some technical issues. But his best wishes are with us through his mail, and we will be getting him shortly over the time if the inaugural session runs for long. So my support to Dr. Zhenxiang over the time for contributing technically to this conference and supporting and believing in us. So that's what about Dr. Xiang. So starting now with the formal things, I would like to invite Professor Jyoti Chaudhary, who is the professor at Hertfordshire, for her address to this conference. Professor Jyoti Chaudhary, over to you.
Thank you very much, and good morning to everyone, and very nice to see you all. I hope you can even see my screen, because what I'm trying to do is I want to ensure that the work does go perfectly. But before I carry on to the presentation, I'm Jyoti Chaudhary. I'm a professor of information systems in Hertfordshire Business School, University of Hertfordshire. I look at how new technologies are being accepted and used within society and organizations. So thinking about it, what would I be presenting today? I thought it would be quite nice just to look at how disruptions are taking place in modern business environments and the opportunities for innovation and technopreneurship. I know everyone talks about entrepreneurship, but there is technopreneurship. So I thought it would be quite nice if I could speak about that, but just for your information, I've put some of my details here. I'm also mentioning this because I'm looking for doctoral students, so Amit knows that. And well, this conference, as Amit said, is not only about presentation, it's about networking. So students come and sometimes they are seeking new supervisors too. That might be something to consider. I'm also an editor-in-chief of Information Technology and People and Emerald Journal. And I've been an editor-in-chief for about 3 years there now. So just before we get into what are the disruptive technologies, again, like last time, I'm going to be talking a bit about how they have evolved. So before
Professor Chaudhary, sorry to disturb you, but your screen is not visible. Can you please reshare it?
Sure. Is this better?
No, we are not able to see the screen.
You can't?
No.
Oh.
So I'll make you a co-host, so it will help you to just share it more easily. So you are the co-host now, so you can share it more easily.
Okay, all right. And can you see it now?
I'm sorry, but I cannot see.
Here? Yes, no?
No.
I don't understand because I've done this in the past and it's been fine. There's been no problem about it.
Your screen was visible earlier, but at this point of time, it is really.
Jyoti, once you share, there is an option full screen sharing. So please try full screen sharing.
Hold on, I'm going to try that. Slideshow. This is amazing and it's really bad. Okay. So full screen sharing, does this come? Yes, no?
Not yet.
No, no, no. Prasad Chaudhary, you can share the presentation on my mail. I'll just open it from my system. That will help, I think. And by the time you can start speaking.
Okay, all right. So just hold on. Let me just do it, and then I will
Yeah.
carry on to that. So just hold on. I'm very, very sorry about this. Never
No,
happened to me before.
yeah. We know there are challenges always in digital presentations, but these are not in physical ones. So we expect everyone to be there next year physically.
Okay, does this come up?
Yes, it comes up.
Yeah. Okay. So as I said, I'll be talking about how the digital technology platforms have evolved. So I'll begin, and I talk about this because I am also known as a specialist of broadband technologies. So broadband in the early 2000s led to the high-speed internet. And as we've got to know more about it, we found that it's all evolved. And this has led to, as the evolution has occurred, we've had online social networks. We've also got cloud computing technologies. And also we've got the digital technology platforms. So, well, why exactly are these disruptive technologies taking off? Well, they're simple, they're convenient products and services, and they're affordable too, and affordable more to the consumer. But otherwise, they're simple, convenient products and services. So for instance, if you've got your smartphone, there is an app over there that allows you to go into an Apple store or a Google store, and you can download and get these disruptive technology platforms. And mostly they are free of charge, so that's why they're simple and convenient, and they are affordable too, because what happens is when you get into the app and you want to use the product or service, because it's free of charge, and usually what happens is they want to attract people, so it becomes affordable. But this has led to new value propositions, lower costs, lower profit margins, and the creation of new business structures. So new value propositions. Before, it used to be, okay, I'm going to the store. If I can get the item, that is something of value to me. But now, because we've got these disruptive technologies, we've got these new value propositions, which are more in terms of speed, quality, also postage and handling, refunds, and so new value propositions are occurring. This has also led to lower costs because these disruptive technology platforms are leading to new ventures, and these new ventures have different business models, and this is lowering your profit margins and creating new business structures. This has also led to the creation of new markets, which has led to the failure of dominant firms. So here in England, what has happened is that now, if, for instance, Amit and the team are here in, say, for instance, Marriott or somewhere, now they do not really need to go down to the restaurant and have something or look around. They could be using their platform and getting their orders into the hotels. And now hotels, restaurants have started to recognize that this might be a new business model where they allow these digital platform technologies to providers to come in and provide products and services. And this has led to the failure of the dominant firms. So before, when we used to have delivery, it used to be DHL and all. Now we've got new companies coming in that are doing the delivery. And now, say, for instance, you've got Uber. Uber is not only a cab company, but it is also doing deliveries. So it's generating significant competitive advantages. So examples of the disruptive technologies, and because we were in the pandemic, I thought it would just be a good idea to look at some of the ideas. And so, first of all, we had Amazon. Many of the countries around the world had preventive measures such as lockdowns, and this led to an increase in the sales of Amazon, because what that meant is people could not go out, and if they needed something, they could use Amazon for that. This also led to an increase and a rise of Getir, a company from Istanbul, and Gorillas and Flick from Germany. But what's happened is, now that the pandemic is over and everyone is trying to get back to normal, actually, countries have started to consider these particular disruptive technology platforms. So Amazon, for instance, is being also looked at for price increases and misleading consumers about the prices they have. Getir and Gorillas and Flick are being looked at in Europe more about causing disruption in the traffic. So if you go out driving or something, now you do have to watch out for the drivers from Getir, Gorillas and Flick, and Zomato and all. And so this is now making countries look at these. And before, there was no regulation about these things, but now regulation is also coming in. So that was one of those about the delivery. Then we've had companies like Gojek in Indonesia, Didi in China, Grab in Singapore. And these kinds of companies have provided competition to the regular high street companies of cabs and such, because Gojek, Didi, and Grab are providing cab services at a rate that everyone can afford. So these disruptive technologies are leading to different business models. What's also happened is, for instance, so that was the delivery. So before, we began with Amazon, and that was more about delivery of products and services. Gojek, Didi, and Grab is more about transport. Then you've got your accommodation, which is the Airbnb and companies like Vrbo. So Airbnb in 2017 had about 4 million customers, and anyone could become a host. The size did not matter. And this was a company started off in Silicon Valley, where someone was short of money and then thought, well, is there some way by which I could get some accommodation and go out, and then got this concept of Airbnb. Vrbo had 2 million in 2017, and this was more about entire homes. Airbnb was about rooms and all, but Vrbo was about the entire homes. However, one thing has to be known, in that during the pandemic, what happened is that sales did reduce. Remember, I mentioned that preventive measures were going on in countries, and this meant that actually people could not go and rent places in other countries. However, locally, these kinds of companies have helped once the preventive measures went. And so the sales reduced, but they're gradually increasing. So in terms of the business model, Airbnb has a fee if you are a host and a guest. For the guest, it's 5 to 15% of the reservation subtotal. But with the host, you charged a 3% fee every time a booking is completed. And it's what everyone talks about is the experience. So I've had some colleagues who have gone out to Airbnb places, and they've come back saying, oh, it was so nice because when I met the host, I got to find out what are the local places to go and visit. I also found out what is a good time to go out and what isn't a good time. Also, what is the area like? Before, we were very reliant on the hotels and the concierge service and all. But now with Airbnb, things are changing. So this is why it says the hosting is an experience. It's not only the friendliness that is coming through, but it's also some of the places that are being offered. they are providing such great service or a product, because, for instance, just as in hotels, there are products that you could use when you're having a shower and all. And so this is why the hosting has become an experience. And Airbnb charges 20% service fee. And now, because of the pandemic going and all, it has found that monthly rents are really important. Recently on Monday in the BBC, they were talking about how in Cornwall, it's become a very popular tourist destination. And this has meant houses are very expensive. Due to that, when people do need to live somewhere, they're actually seeking Airbnb places, and they are renting them monthly. Verbo, on the other hand, again has a fee for the host and the guest. And for the guest, it's a 6 to 12% service fee. You can see at the minimum, it's a bit higher, but at the max, it's a bit lower. For the host, there is a subscription fee, and there is a pay per booking, so 8% for less than 6 weeks. And there is an annual subscription where someone could be charged $499 upfront for the year. So these are the kinds of business models that are coming up. So what I tried to do in today's presentation, well, as Amit mentioned, we are out of the pandemic and we've got to start thinking about what are the business opportunities out there. But before I got into that, I talked to you about the evolution and how actually in the early 2000s, people were still trying to figure out what are we going to do with this concept called the internet. And yet now we're so reliant on it during the pandemic. And even now we've got Zoom, we've got Teams. Again, they are disruptive technologies. And then they are providing opportunities and technopreneurship. So I hope I've helped you and also brought this session to a good start. So thank you very much. Any questions for me?
I think thank you very much, Professor Chaudhary, and it was a nice talk you have been given. Our businesses which have changed over the time, and with time it will change more. So we have to be ready with that.
It will, and the thing is, as we are learning more about the business, the disruptive technologies, new concepts are coming in. So, for instance, we've got Zoom and Teams. And now there are going to be more platforms coming out.
True.
Maybe because of the meta concept that Facebook is bringing out, we're going to have more of the virtual reality concepts coming in. But we've got to even think of, like, for instance, security. This morning, they've been talking about security in the metaverse app. So these are the sorts of things even we will have to think about. With Airbnb and Verbo and all, there are security issues as well. So if you are going there, is the person genuine? Is there security for a person? All these kinds of issues even need to be addressed. So, well, I hope I've helped. Any questions?
Yeah. I think if you have any questions, you can just ping her in the chat box and she'll be happy to reply. So thank you, Professor Chaudhary. And now moving ahead to the next speaker, we have with us Mr. Anando Bose, who is a executive editor of Springer Nature and is working with us with our collaboration since the inception of this conference. And we are really proud to have him. So over to you, Mr. Bose, for your talk.
Yeah, good morning, everyone. Good morning to you from London, to be very honest. This is after 2 years, we have an opportunity to travel and, come to London. This is like 2 very rough years we had, everyone. But hopefully there's always a light at the end of the tunnel. So I hope that, we will, the pandemic will be over soon and we will be able to meet again. And I can see some faces over here. I really wanted to meet them personally and physically. Jyoti is here. I can see Professor Raikov from Russia after a long time. I can see him, Dharam Singh ji, and Dr. Peng and Vijay ji, and all. They are all here. And it's so glad to see them, still virtually. But honestly, I can tell you this, after a long time, we had a physical meeting of ICICT, which happened on 21st of this month, just a day before. And we had around 10% presentations there. As Amit said in the beginning, when this whole this conference started almost 7 years ago, we have received 200 papers, and the mostly local papers from India, and we published around 50. And Amit was not very happy with it. He said, I don't want to do another conference where I want to publish all these papers from India only. So what is the next step? What can I do? So I still remember we had a lot of talking at that time and planning and all. And in 2019, we saw the fruit, and we had people from almost 45 countries sitting in the hall. And I was so amazed to see the kind of collaborations people were having. Those interactions were so very beautiful. And I hope things will be same next year. This year we had a very small gathering, and I think 90% presentations will be online. And I can see so many people are on the chat. They are saying my paper ID is this, and their name are reflecting over there, and they are coming from different countries. So good to see you all. Before any further ado, I will just give a small talk. I will just give you a brief presentation very quickly in 8 to 10 minutes. This is basically talking about publishing tips, and these are the tips which are basically useful for people who are doing research, because sometimes internet is always helpful. As Jyoti said, we were not even aware of what exactly is internet before millennium, but in last 20 years our life has changed completely. But definitely, if you look at it in these tips are available everywhere, but it's so vast, information is so vast, and data is so abundant that we really don't know how to look for it and where to look for it. So I will give you some basic tips quickly so that you can actually look for them and you can read them more and you can go deep dive into it. A little about the organization I belong to. You all know Springer. Springer is now Springer Nature, because last 7 years we had a collaboration with Macmillan Science and Education. The name has changed. This is a company started in 1842 by the person you can see on the slide, Julius Springer. And in 1924, after the First World War, we actually came out of Berlin and opened another office in Europe, that is in Vienna. And after the Second World War, our biggest office came up, in Heidelberg. Now in Springer Nature, we have almost 10,000 plus colleagues, and we operate from 50 different countries. If you look at Springer Nature portfolio, we are completely into academic book publishing, and we are one of the largest academic book publisher. We work all across research areas. We started with mathematics and engineering, then moved into core science and then medicine. And finally, in last 30 years or so, we are into humanities and social sciences too. In 2015, we actually started with another organization, which is a part of us, is like Palgrave, and Palgrave have very good content. We publish almost 13,000 new books each year, and there are more than 3 lakh books which are available online. We really understood the potential of online publishing in last 2 years, when we were not able to reach our customers through printed material, through anything through all other platforms. The only digital platform was working. And you won't believe that the numbers of downloading was so high. It was like more than 2 billion downloads in the whole year, and we were not expecting this much. It took us a lot of time to manage everything and reach all our readers, and we are very happy that we are able to do that, because we started pretty early with the digital thing. So quickly, some tips to you. The first thing is copyright, which is very important. And you all know that whenever you publish anything with any publisher, that you have to transfer the copyright. And I want to highlight over here, you all know the meaning of copyright definitely, but I want to show you the, the logo over here, which is on the right hand side, which is called COPE. If you haven't heard about it, so please type COPE on Google. That is Committee on Publication Ethics, and all good publishers are member of COPE. So I especially tell you to go to COPE website and see what exactly the documents are available. They will talk about copyright as well as all different ethical issues. It's a platform where you can have online discussions also. It's a platform where you will be able to read many case studies on ethics. And it is very important for anyone who is basically working in research or doing research. Ethics is very, very important. Then we have something called plagiarism. I know plagiarism is a very derogative word and nobody wants to get associated to it. But definitely there is something called fair use. And fair use is basically how much content you can use from someone else's work or from your own work. So there is a document called Association of Research Libraries 2012. If you get hold of this article on Google, then you will get to know what exactly is fair use. But at the same time, my suggestion or advice will be, in case you are using anyone's content, or even if you're using your own content which is already published, please go and take permission, take copyright permission, and then go for republication of that thing. Don't use that content again without permission. Self-plagiarism, if you are using the same content of yours without taking the copyright back, without taking permission, that is called self-plagiarism. And people are doing a lot of self-plagiarism and getting into the trap, and papers are getting retracted or the papers are getting removed because they don't know what exactly is self-plagiarism and they fall prey to this. So what exactly you have to do to take copyright back, that is very important. Whenever you publish anything with a good publisher, an article, a chapter, or a conference paper, you always go to the homepage of that paper and you will find there is a button or there is a link which says reprints and permission. Or in other, this is like a screenshot taken from Springer Nature, so the people might use different languages over there or different wordings, but they are basically talking about reprints and permission. So when you go and click this reprints and permission, a page will open that is rights link. You can go to rights link page and you can actually take back the permission and use the content again, whether it's your content or someone else's content. There is always a possibility to take the permission back. Now, another important thing is sometimes people, they come and they get lost in the website and they don't know how to approach an editor. So this is a screenshot which has been taken from the first page of Springer.com. If you go to our website, you go to the link subjects, and under subjects, you will find there are all different subjects are over there, listed over there. And you can, suppose you're looking for something in computer science, then you can directly go to the computer science link. Or else if you are supposed to looking for something like mechanical engineering, then you can go to engineering, and in engineering page you can go to mechanical engineering. And on every page you go to the subject page, you will find a contact link. So if you go to that contact link, then you can see the name of people who are dealing in journals and books separately. From there you can contact the Springer person very easily. There's another important tool which I want to tell you about is Reviewer Finder. Reviewer Finder is a tool where you can find a reviewer for your work, because nowadays, it is very, very important as well as mandatory when you submit your article to a journal or to a conference organization. They ask for reviewers mandatorily. They ask you to name some reviewers, although you don't have to be worry that people will send your paper to those reviewers. No, it is not. We are not going to send the papers to the reviewers you have basically suggested. It will go to some other reviewer, but for creating that panel, we have this. But definitely Reviewer Finder will help you in another way. People who are working in your area and who are reviewing in your area, you can also collaborate with them. So you can search for people who are working in your area with this tool. Then we have a page which is basically helping authors, talking about all the guidelines and the services. And this is a kind of a page where you will get a lot of different links. You can go to that page and you can refer it for again and again whenever you need it. So this is under services. If you go to Springer.com, under services, you will find there are authors. So we have separate links for journal authors and book authors. And you go to book authors if you're looking for some content over there. And there are huge resources available, which you can go to time and read at your leisure. There's another tool, which is a very interesting tool, which is called Shared It. We started this 3 years back. We started with journal. Now we are doing it with for conference proceedings also. What exactly is Shared It? When you publish a paper or a conference proceedings paper with Springer, then the production team, give you a link, share it link. So this link you can share with anyone, and people will be able to see your paper, complete paper, legally. They cannot download it, they cannot print it, but they can annotate it, they can read it. So what is the basic idea behind it? It's like, sometimes you are searching for a paper and the paper is not subscribed by your institute or library, then you cannot read that paper. But there's a possibility here. If you are in that situation, then you can actually write to the corresponding author of that paper and you say, please share it with me. So legally, the author can share it with you. And if you are an author, then definitely you can legally share it with your community and they can actually read the whole paper. So this is a very, very interesting tool, which is actually helping to share your content with the community. Then we have something called ORCID ID. And if you haven't heard about it or you don't have it, as a researcher, you should go today itself have ORCID registration ID, because this is an ID which is going to give you unique recognition, because this is a unique ID. It is not going to confuse your name with any other name, and your work will be properly recognized and cited if you have ORCID ID. Then this is a page where you will find on springer.com, springernature.com/in/policies. This is a very interesting page where different policies are outlined and you can actually read them. Again, not necessarily at one go. You can go at your leisure time. You can actually open these policies and read them. There are editorial policies and there are research data policies, which is very important because everyone is using data nowadays. And there are lots of policies are attached to of using how to use and how to interpret data. So these policies are very important. And now open science is the buzzword and people are talking about open science. Open access is just a small part of open science, but there are policies which you need to know before you want to publish anything in open access. This is a blog, The Source, our content marketing team, they actually manage this. And this is again a place where you can go and you can communicate socially with people. You can write blogs, you can read blogs. So this is another important page where you can actually share your thoughts, share your research with the community. We'll quickly talk about 4 books before I conclude. And these are the 4 books I think always good for researchers to look at and keep on their table so that they can refer back again and again. The first one, you can see How to Write and Publish a Scientific Paper. This is written by Robert A. Day first, then Barbara Gastel joined. This is the 8th edition cover. 9th is already out. 7th is already available free of cost. The PDF is available on Google. So if you really want to download that, you can download that also. Or else this is a purchase you can do on Amazon or any other website. And this is a good read one time and also can be referred again and again. Then there is a book called Getting It Published by William Germano. This is talking about all the nuances of publishing. There are lots of questions which comes to your mind, but there is no answer available immediately. But these are the books which will give you answers whenever you need them. Then there are 2 books. First one is Textbook of Research Ethics, written by Sana Lu. And this is a very good book. This is used as a textbook in many universities. And if you haven't read this book and you don't know about this book, you should go to springer.com and download this book. This is a very, very nice read. And finally, there's another book for engineering research methodology, people who are doing their PhD right now, and they are in the engineering stream. This is a nice read, and this is a nice book which was published almost 3 years ago. So thank you for giving me this opportunity today morning. And my message to you is work sincerely, focus on quality, say no to academic corruption. We know everywhere there is a corruption. Stay away from it, stay happy. If you have any questions, I think people always have questions when they go back and they use these contents and on all these tools. So my email ID is here, anindo.boss@springer.com. So you can actually write to me. I will be very happy to answer your queries also. So have a fantastic day of presentations and good luck with you. Tomorrow also we will have presentations. So of course online. Enjoy the conference and enjoy the talks. Thank you. Thank you so much.
Thank you so much, Mr. Bose, and it was really an inspiring talk to all the researchers. Thank you. So moving ahead with the next schedule of the inaugural session, we have with us Dr. Mike Hinchey, who is the president of an International Federation for Information Processing, as well as an associated partner of this conference through IFIP since the 2017. So I'm really proud to have you. So Mike, over to you. Uh, I think Mike has just been out, so I think we will wait for him for the next session. But moving to the next speaker, we have with us Dr. Day, Dr. Nilanjan Day, who is one of the editors of this conference, as well as an associated partner of this conference since the inception. And he is working with JIS University in India at a designation of associate professor. Lots of credit in publications and citations. He is one of the most cited researchers in Asia, and he has lots of books and papers to his credit. So I am happy to have you, Dr. Day. Over to you for your address.
Thank you very much, Amit. So very good morning to all of you. There are many, again, as Anindra mentioned, there are many known faces who we are also eagerly waiting to meet personally. Professor Milan is there, Professor Peng is there, Vijayji is there, and lots of other known faces. So a very good morning to all of you. Hope next year we will meet physically in London. Let me share my screen. So it's a little bit of technical topic, but I will take not more than 15 minutes. So I'll try to conclude the talk within 15 minutes. Sorry. Amit, my screen is visible?
Your screen is visible, but it's a white screen.
It's blank.
Yeah, it's blank.
Now?
Can you reshare it?
Okay, 1 minute. There is some problem.
Yeah, now it's perfect.
Okay. So I'm going to talk about pattern recognition in small data, which is very challenging problem, because if your data size is very less, in that particular very less data, if you try to find out some kind of pattern, it is always very challenging task. Now, once we talk about pattern is a kind of repeated sequence, or you can say it's a kind of regular way that something is happening. Now, once we talk about pattern, a very common pattern comes into our mind, which is called Fibonacci series. Now, this numerical series pattern, you will see if we try to come up with the square, taking the widths, it always gives something which is a ratio of 1:1.6. That is called a golden ratio. So in nature, we generally used to find such kind of patterns starting from rows. Maybe if you look into the Mona Lisa, if you look into the continents, if you look into the fingerprints. So everywhere there is such kind of pattern which actually comes from Fibonacci series. Now, patterns are not exactly the same, but what we try to do, we intend to capture the approximation. So we are trying to impose some pattern. Now, why we try to impose that pattern, we will try to understand. So everywhere we are actually trying to impose some pattern so that we can conceptualize the information in an easier way. Now, this golden ratio is an example, but apart from these, there are many other cases where we always try to impose some pattern. Now, if you look into this particular figure, you will see that we are trying to complete the incomplete picture. Now, we are trying to impose a pattern. Maybe it's a circle or maybe it's a square. So actually, it's in reality, it's not that. But we try to impose some pattern just to complete that figure. Now, if you look into the human memory are three different types. One is called sensory memory, one is called short-term memory, one is called the long-term memory. Sensory memory, where the retention capability of the information is less than 1 second. Short-term memory, less than 1 minute. And long-term memory is a lifelong memory. And lifelong memory are two different categories. One is called explicit memory, which is a conscious, and implicit memory, which is unconscious memory. And explicit memory is a declarative, maybe it's a facts or the event based. It can be episodic memory also, or it can be semantic memory based on the facts or the concept. And implicit memory is a procedural kind of memory where we actually try to do some task, or say maybe we are trying to do some skill, which may be a lifelong memory or a long-term memory. But human memory having very limited capacity to, come up with, storing those information, very less capacity. So it's a 7 plus minus 2 numbers of chunks. So in 1956, Professor Miller comes with a report, and he reports that this capacity is very less. It's 7 plus minus 2, not more than that. So you need to store the data or the information within that particular slots or that particular chunks. Now, human memory, you always try to recall the sequence in order or recall the sequence in any order. So these are the two cases. One is recall the sequence in order or recall the sequence in any order. So if you look into this pattern, it is always difficult to memorize this pattern. Now, if you simply change this position of T and if you take here, then something it looks like the cat run up the tree. And now you'll be able to, it will be easier for you to recall these things. So the sequence will be easier to memorize. So that's why we always try to find some pattern. Now, once we talk about measuring the memory, there are 4 different kinds of measurement of the retention of the information. One is called reintegration, one is called relearning, one is called recall, one is called recognition. So what is reintegration? It's a kind of, if I have a complete memory, if I try to come up with a complete memory from a partial clues. Based on the partial clue, I will provide partial clues, and based on that, I will try to fill the memory or complete the memory. So this is called the reintegration. Now relearning is, I have a certain level of competency level, and we are trying to reach that level. Then how much time it will take to reach that competency level? That's called the relearning. Recall, if I don't have any kind of clue, then if I try to come up with some memory, if I try to gather those information, it's called a recalling. And the last one, which is called a recognition. Recognition, where the original content is actually we are trying to reproduce without taking any kind of help, just to identify it correctly. So that is called the recognition. So this is interesting part, that the last one is the recognition, which is actually linked with pattern recognition. So if you look into these numbers, it's very difficult to recall all those things, or if I try to recognize this pattern. But once you try to impose some pattern, maybe the helium is 2 or the lithium is 3 in this way, then it will be easier for anyone to recall it, or maybe to recognize those patterns. So that's why pattern recognition is a cognitive process, where we are trying to match those information which are already stored based on that. So recognition is a recognition, the process of knowing an entity, or the process of knowing an entity again. It's called the recognition. So this is what pattern recognition actually is. Now, once we talk about pattern recognition learns from the data. So data is basically the fuel. So you automatically try to identify the patterns even when there is a partially visible, or you can say the recognized pattern which we are already familiar, we are trying to impose that one. So in this way, from the data itself, we try to identify, or we try to impose some pattern just to memorize those things within that short memory, that is 7 plus 2 chunks. Now, as I said, the fuel is the data. Now the problem is, in machine learning, it always depends upon the data which we are using for the training purpose. And it's very much sensitive to the data which you use. Now, if you feed some garbage, the output will be definitely garbage. So always the training data needs to be very clean data. So we have to identify, we have to correct the data, which is a so-called bad data. Means inconsistent schema, means extraneous text, maybe missing data, redundant data, contextual data, maybe garbage values. So all good data are alike, but each bad data set is bad in its own way. So we have to identify those bad guys, and we have to rectify them, we have to correct them, so that they can come into the mainstream or main pool, you can say. Now, how much data is good for machine learning? So is there any heuristic mechanism? As such, there is no mechanism or heuristic strategy just which will tell that this much number of data is good enough for machine learning. So always, as the bigger data size is, as the clean data is available, it's always good for pattern recognition. So you always try to identify good data. We are always try to gather more number of good data for machine learning purpose, as well as to identify the pattern in a very easier way. So, as I said, deep learning is a kind of memorization technique. So what we try to do, we are trying to come up with a model of, you can say, interpolation from the training data. So there is an absence of underlying behavior. Means we don't understand the underlying relationship in between the variables. And that is a major challenge of any kind of machine learning algorithms, deep learning specifically. Because neural network doesn't have that capability to understand that inherent relationship in between the variables. So just to overcome these things, what we need all different aspects of variations. Now, if you need all different aspects of variations of data, it's not only the big data, rather which you need to provide, it's variable data. So as much as variable data, variable patterns you can train your system, the system will be much more robust for any kind of learning mechanism. So our intention is not train the data with large number of data, rather we will try to, put the more number of variables data so that it can identify something little bit of understand that inherent pattern in between those data. So it's always, there is a lacking of learning abstraction. If you look into the polyfit curve, if you see the number of points, if I increase, the fitting will be more generalized. So if a linear regression number of point increases, it will be the point estimation will improve. See, for example, KNN, if the number of data point increases, you can see the predicted class will be different. Now, if you change the splitting of a tree, automatically the splitting will be different for more number of data. So all those generic form means all those, you can say, better generalization purpose or better improvement purpose. What we need more and more number of data. So data is important, but the problem is there are many cases where there is a problem of availability of the data, crunch of data, like say so-called healthcare data, because we don't have that kind of large data. So from that particular small scale data, small size data, it's very difficult to identify the pattern to come up with this memorization technique. So for that, what are the challenges? The challenges is always it's revolve around the high variance because the size of the data is less. Another thing is the overfitting cases, because it's always overfitting cases is something where you can see if you train with your machine, maybe the validation, after some time the training accuracy is increasing, but the validation is not increasing. Maybe it is dipping, or maybe outlier cases. Sometimes it is very dangerous. If the data size is very less, if there are outliers, actually machine learning not works fine. So these are the few issues which are associated with small scale data, small size data. But this is very common. We only not talk about big data, rather we should talk about small data also to find out the patterns. Now, there is a huge data set which is called the ImageNet data set, which is given by Professor Lee from Stanford University in 2009, where there was 14 million data and 80,000 distinct class. Now, these 80,000 distinct class, initially there was a 28% error rate in 2010. But after that, the error is getting lesser and lesser. And now it's below 2%, less than the human error rate. Now, the interesting part is how many numbers of intermediate nodes and parameters you required. You need 60 million parameters to tune it, or 6.5 lakhs of intermediate nodes just for 1,000 categorization. Now we are talking about 80,000 categorization. Think about the complexity. How big the number, what is the number of the parameters and what will be the number of the nodes? So it's a huge number. Now, there is also another problem. This is a huge data set for benchmarking, but is this foolproof? Okay, the issue is in real life, we used to take the object from different angles, from different backgrounds, from different lighting condition, their uneven illumination, etc. Now, objects might be partially occluded, might be shadowed, there might be different issues. So in vision computing, we not actually try to replicate the same object, or we try to recognize, we don't have the capability to recognize by AI. But our human intelligence is that much, it can identify that occluded part. It can fill that part so that it will be easier for recognition process. Now, CNN is always, convolutional network is always good for, you can say translation, but not good for rotation and scaling. The problem of ImageNet is most of the images which is stored in ImageNet, that 80,000 data, all are so-called good data. Good data means they have taken from a proper position, they have actually captured in a good lighting condition, etc., etc. So in ImageNet, chairs looks like something like this, but in reality, the chairs are not like that. So that's why the variability is very important. So even though we use ImageNet for benchmarking, but there is some fundamental flaws because this data set is completely you can say biased, because it's all taken from a proper lighting condition, illumination condition, etc., etc. So that's why variable data is important for small data also to identify the pattern. Even in CNN, it's failed to identify that these are all same, because don't have that capability to make the machine and understand. I mean, it should be understand that these are the different case studies, different scenario, different rotation. So otherwise, it's not something very much creative like human mind. So yes, it is always good to invest time and money into gathering more data, so that the pattern recognition process will be much more easier. So we should spend more time and money to gather data rather than working with small data. Thank you very much. So if you have any query, you can write, or here is my mail ID. You can also write.
Thank you very much, Dr. Day. It was nice to listen to your presentation on the vision computing and address the message to the audience. Thank you so much. And I think I'll just check out if Mike has joined. No, Mike hasn't joined. So we will be moving ahead to our next speaker, Professor Milan Tuba. So Professor Milan Tuba is one of the colleagues which we have been associated with since this inception of this conference in London, America Square. I still remember we had the first conference at America Square. So we welcome Professor Milan, who is the Vice Rector of International Relations at Singidunum University, Serbia. And over to you for the address, Professor Tuba.
Good morning. I'm very happy to be here again. Actually, I was much happier. I don't know, was it the day before yesterday when I was in London? And finally, after 2 years, I hope we will start getting back to normal. And I'm sorry if I look a little bit tired, but you know, there are some, well, I would say, sweet problems with the traveling. So you could see on TV that on Friday, planes had problems landing in UK. Many of them didn't succeed at first. And then also on the ground, there were trucks and buses overturned on the highways. And also on my way back, I had a journey from central London to Gatwick, 2.5 hours, and then waiting, delay 2 hours, and then only hour and 50 minutes to Budapest, but then again, whole night to Belgrade. But as I say, it's good that finally we started this time, this combined model, and next time I hope we will all be together in London and everything will be back to normal. So what I would like to mention is a different aspect of the same topic that Professor Day discussed before, because it really is a very hot topic today. I will put this presentation, but really in 10 minutes I will not cover a lot of that, so don't pay too much attention to this. Again, you see, it is about digital image classification, the same topic that Professor Day was discussing. And what I would like to emphasize more is that here we have a very special situation. In general, research is an important area of human development, and we have different areas and we have different advances, but occasionally we have something that is revolutionary, something that is extremely important. And we may remember in computer science, let's say, that development of personal computers, and then later development of internet, and then later smartphones, and few other things. These were not really comparable to other incremental developments. So right now we have another one, and that is, well, it can be named from different perspectives, but in general, it is about convolutional neural networks and image classification. Just let me see. It seems that this keyboard doesn't work. Maybe I can do it somehow here. Oh, yeah. Okay. And you know, when you say PC or internet, it now looks clear that it is a big thing and it was a revolutionary step some time before and so on. But when you talk about convolutional neural networks or about digital image classification, for ordinary people, it sounds rather scientific or not so familiar. Then again, when you explain that, let's say, unlocking the phone with your fingerprint or unlocking the phone with face recognition, that is actually the product of that technology, then they understand that really it is something that is around us, that is influencing our everyday lives, and that is really a revolutionary step. So we can discuss certain aspects of that technology looking at, let's say, medical diagnosis, because it has been done in old Egypt and it's been done today, so we can see what are the differences and what are these revolutionary changes. It's also applied in some new areas that we didn't have before. Let's say cars without drivers, self-driven cars. That is something very new. We didn't have cars 300 years ago, let alone self-driven cars. And now it looks like something very different. What is the connection between self-driven car and curing certain illness or medical diagnosis or something like that? It looks that there is no connection. But actually, from the point of view of artificial intelligence, we are dealing always with the same problem. The most important problem is classification problem. And classification of something, but most often it is a digital image. So digital image is again this new revolutionary element that we didn't have before. And classification of digital images is really a basic step, but it is a foundation of practically everything that we have. So in medical diagnosis, we are collecting digital images. We couldn't do that before, but let's say starting 20, 30, 40 years ago, it was possible to use old technologies like X-rays, which were available 100 years ago. But now it is very different if you can make a digital X-ray image, because for regular X-ray machines, it was revolutionary. Yes, you can look inside human body for the first time, but you have to have a very trained expert with very good eyes and very good conditions. And then he can real-time look inside that human body and try to figure out these small important details in a very unfriendly environment, because even though X-rays are showing inside human body, it is not showing it in a way that we would like. Let's say, is there any tumor on this kidney? And then it will turn out as a red area and you immediately can see it. It is so subtle change that you have to have a very good, very trained expert, and a expert that is physically very fit with his eyes and everything, so he can discover that. However, if we have a digital image, then the situation is much, much better, because now we can use computers to analyze that image, and computers can discover in that image some things that humans cannot, because our eyes, the way that they are able to recognize certain things and not able to recognize some other things. In digital image processing, you can do practically anything that you want. So you can even look for things that were invisible to human eyes before, and you can do much more complex analysis. And then finally, what you want to do is you want to make a diagnosis. And that is actually classification problem, because you look at those images and you want to answer certain question. Is this liver healthy or not? Or is disease A present on this liver, or disease B or C, or none of those, or whatever? So you are doing medicine, you are doing medical diagnosis, But when you come back to the lower level, it is digital image classification problem, and all techniques apply. If you look at, as I mentioned, something completely different, and that is self-driven cars, then it looks like something that has nothing to do with medicine. But again, how can you drive a car without a driver? Well, you need a lot of sensors. Most of them can be cameras. So now you will have, instead of static images, you will have moving images, but then moving images are sequences of static images, so you can look any way you like. And then you can have a front camera, back camera, side camera, and so on. But you can also have infrared camera. You can have some ultrasound devices that will be used for measuring distance. You may have laser devices. You may have certain things embedded in the road or around the road that will help you also with other types of signals. So practically you will get a lot of information, but let's say most importantly from cameras. And now you have to analyze that in real time. And in that analysis, you will use a picture, an image, and then you will try to figure out, is there a traffic sign? What kind of traffic sign is that? Is it stop traffic sign? Is it speed limitation, 60 kilometers per hour or whatever? And you have to make, again, digital image classification. And then after that, based on that decision, you can use some robotics, and then you can issue commands like turn the steering wheel a little bit left, a little bit right, a little bit more to the left, start braking sharply, not so sharply, and so on. So everything after that is some kind of mechanics or robotics, but the brain part is, again, digital image classification. So that is what maybe most people in the world don't know, that this revolution about convolutional neural networks and image classification is actually affecting lives of everybody now. It is a revolutionary step, but it is somehow hidden behind these scientific terms, and you need this short explanation how it really works. Now, how that happened? Well, that happened, as Professor Day mentioned, first we have data. And we should have a lot of data. And a lot of data became available with the technological revolution. But let's say these smartphones and cameras on smartphones are really supplying enormous amount of data. And as you saw in this database that is used for benchmarking, you have hundreds of thousands of images. And, 30 years ago, it would be difficult to collect that many images. Now, with this technology, it's easy to have a lot of data. And also, you need a lot of processing power, because with that amount of data and algorithms, which are non-deterministic algorithms, training neural networks is really computationally hard problem. You need something different. So actually, even though we had Moore's law, and we have every new generation of processor is much better than the previous one, and you had, let's say, Intel processors, generation 2, 3, 4, 10, 11, 12 now, and so on. And each, the last couple of years, it's really not revolutionary anymore. But before that, it was better and better processors. These steps were really insignificant for what we needed here. So graphical processors really, with a lot of parallelism, with thousands of small units that can work in parallel, made it possible to attack such problems. And then, of course, on professional level, you have much more powerful computers, but for the, let's say, regular everyday research, you need at least a couple of good graphical cards, and then you have enough computational power to tackle those problems. And then with that enormous amount of computation and enormous amount of data, we get some revolutionary results. And what I want to mention here is that this is a situation where we have a blessing and curse mixed in the same thing. Because how can we deal with that amount of information? Well, it's not humanly possible anymore to go and see all the details. in old times, let's say old Egypt or Greece or whatever, you had some kind of medical experts, and what they can do to diagnose a disease. They can look at a person, they can look at the skin, eyes, teeth, try to figure out what looks wrong, ask a question, does it hurt here, does it hurt here? But it's really, what is that? That is selecting features from a person. You have millions of different persons in the world, and now you have a specific person, and you have a feature attached to each of those persons. So that is a texture of the skin, of teeth, eyes, and so on. And you select few of those features, and then you try to make a medical decision. If your skin is yellow, then it means something, maybe your liver is not working well, and so on. And then later you had improvements. For example, you have blood works. And now you get dozens or maybe 100 different results. For people before, it may look like a miracle. You get a person, you don't see anything, and now from some blood drawn and some technology, you get a lot of information what is going inside that person's body, and you make much better diagnosis. For people that don't understand those new features, what are red blood cells, white blood cells, kalium, magnesium, whatever, it looks like a miracle. You know, you are using some strange features and you are predicting diseases much better. However, it is important that we have experts that understand all those things. Majority of people don't understand, so it looks like a miracle to them. But it doesn't matter. There are experts who know exactly what are the features and how we interpret those features. So you can again increase that number. You know, this Terranos thing last, now it was interesting because of that lawsuit where the promise was that from one blood drop you can get hundreds and hundreds of different results. Well, that failed, but in general, in the future, it may be possible. But the important thing is that we always understand what are the features. However, that is a limitation. How many features can we deal with? Can we deal with 10 million features? We don't have enough time. It's humanly not possible to write a book with those 10 million features and see what they are and how they interact and what is their meaning and so on. The beauty of convolutional neural networks is they do automatic feature extraction. They take all the raw data and then they make millions of different features for which we don't have names. We know what is eye color, we know what is skin texture and things like that. But here you have 10 millions of different features. They are hidden somewhere in that convolutional neural network, but we don't have not only names, so we don't have any idea what they are. However, convolutional neural network is a self-teaching mechanism. It uses all these features and tries to figure out what are the relations, what are more important, and so on. And finally, it comes to the decision and say, well, this is the diagnosis. And what is good is that that result is very accurate. It is in practically all cases today better than human expert. So whatever you are doing, medical diagnosis or something else, if you have human expert on one side and you have a convolutional neural network, human expert will make something like 99%, 99.5%. Convolutional neural network will make more than that. Error rate will be even smaller. And we are very happy about that we can use that self-learning mechanism to get results that were not possible before, results that are humanly not possible, that go beyond what a human can handle. However, it's also dangerous because sometimes errors will happen. That will be in very small percentage. Let's say human will make an error in 1%. Computer, convolutional neural network will make error in 0.1%. So it is 10 times better. This one makes error 10 times in 1,000. This computer makes 1 times in 1,000. But with humans, we are somehow inclined to be forgiving because those errors will be expected, you know. somehow, you know, I don't know, kidney, liver, they are close to each other. I don't know. If there is error, we will try to understand and say, yeah, it's possible to make such an error. When a convolutional neural network makes an error, it can be completely unexplainable. It can make something that we can call stupid error, where it will, you know, misdiagnose some foot injury for, I don't know, brain tumor or something like that. And you say, well, it's ridiculously stupid. How can you? Yes, it is an error, but it's impossible error. What is the connection between human brain and human thought? How can you make such an error? The problem, and of course the good thing, is that neural networks is using different features. We don't know what these features are. In these features, brain and foot may look similar in some way. So when you make an error, it will not go from foot to knee. It may go from foot to brain. Now, do we want to say, well, it is better to have 1 in 1,000 rather than 10 in 1,000, and that one may be very stupid? Or we want to have 10 people misdiagnosed, but with something that we feel better? Well, that is really interesting question. So on one side, we have magnificent results, and as a research topic, it's very good. You can make progress wherever you start, because, you know, it's very powerful technique. There are no limits practically what you can do, but also we have these other philosophical discussions of how to deal with this new technology, because it's really now imposing a new challenges. So I think for this short speech, that would be enough, and hope to see you in person next time. Thank you, everybody.
So, hi, Professor Juba. Thank you so much for your presentation. And I think authors must have taken a note from your side that failures will happen, but we have to try always. So, thank you so much. And we are at the end of this inaugural session. And before me, I'll speak the final words, because I think Professor Mike has not yet joined, and I really don't know the reason. But let me check out, and he would be addressing in any of the technical sessions soon after this inaugural session. So I'll request everyone to just open up their camera so that we can just click a photo.
Yes.
I can see now a lot of faces. Dr. Dharam Singh is here from Namibia. Professor Pang is here from Taiwan. Then Professor Raiko is here. Vijayji is here. A lot of similar faces. But next time, I would like everyone to join physically. Another 10 seconds, and then that's done. So thank you so much, all of you, for sharing your cameras and just for the clicking a photo. But we are at the end of this inaugural session, and I hope that deliberation in next 2 days in 43 different technical sessions chaired by 43 different chairs would be fantastic, and there will be a lot of things to learn upon. So I request everyone try to spend some time to be in the technical sessions, listen to the talks, and you can have some digital collaborations. I understand that it would be difficult, but there are hopes. There are high hopes that it will happen. So with these hopes, I'll leave you all for the fantastic 2 days deliberation, and look forward to see you physically for the 8th edition of ICICT in London in next February 2023. So thank you so much. Thank you, everyone. And I look forward to the sessions, and I think it will start around 12 London time. So just look forward to The agenda is on the website icict.co.uk. Anytime you just need to find any person speaking or anything you want to know, just go there, put your thing in the search, name or time or the schedule or the session. You will find your schedule there and there. If you have any queries, please mail the support team at support@icict.co.uk. They will be really happy to help you in the best way possible. Thank you so much. And the chat box is still on. So if you want to share any greetings or anything, it's open for next few minutes.